Classification of memory systems. So firstly, what is memory? Memory is just like our human brain. It is used to store the data, information, and instructions. We can say that it is a data storage unit or a device. So memory systems are classified mainly into three types. First is volatile and non-volatile memory. Another is random access memory and sequential access memory. And third one is RAM and ROM. Now let's see what is volatile and non-volatile memory. In volatile memory, data is lost when the power is off. It is temporary storage memory, and in non-volatile memory, data remains the same and stored when even if the power is off, and it is a permanent storage memory. So this is the difference between volatile memory and non-volatile memory. Data retention, data lost when power is off, and in non-volatile memory, data retains even if power is off. Now speed, volatile is faster and non-volatile is slower. Cost, volatile is expensive per bit and non-volatile is cheaper per bit. The examples are RAM for volatile memory and ROM for non-volatile memory. And as volatile memory is depends on power, if power is off, the data will be lost. So it consumes more power when active, and non-volatile consumes only during write and read operation. Now random access memory and sequential access memory. Random access memory, any data can be accessed directly or immediately regardless of its location. And in sequential access memory, data is accessed in a specific order. As per its name, we can get to know that is it will be sequentially accessed. Now the difference, random access memory and sequential access memory. Access method will be random and sequential. Speed in RAM, speed will be faster, and in sequential access memory, speed will be slower. And examples of RAM is SRAM and DRAM, that is static RAM and dynamic RAM. And in sequential, magnetic tape and optical disc are the examples. Cost of RAM is more expensive, and sequential access memory is more cheaper. Now third type is RAM and ROM. RAM stands for random access memory and ROM stands for read-only memory. Now RAM is only used for temporary storage of active data and enabling the fast access by the CPU. And ROM stores the permanent instructions and data that cannot be modified and used for the boot processes. Now the difference, data storage, RAM is a temporary data storage memory and ROM is a permanent data storage memory. RAM is a volatile memory, ROM is a non-volatile memory. In RAM, read and write operations are allowed, but in ROM, primary read operations are allowed. Some can be rewritten, that is EEPROM. Now, the speed of RAM is faster as compared to ROM. The cost of RAM is expensive, cost is more, and ROM is cheaper. Types are SRAM and DRAM, and in ROM it is PROM, EPROM, and EEPROM, flash memory. Now, RAM memory, that is random access memory, is again converted into two types, that is SRAM and DRAM. SRAM stands for static random access memory, and DRAM stands for dynamic random access memory. So let's see the difference. Data storage, SRAM stores data using bistable latching security, that is flip-flop, and in DRAM, data stores in capacitors. Speed of SRAM is faster and speed of DRAM is slower than SRAM. Now volatile, SRAM is a volatile memory, DRAM is also volatile memory. Power consumption, SRAM consumes more power and DRAM consumes less power as compared to SRAM. Cost, SRAM is more expensive and DRAM is cheaper. Now why SRAM is more expensive and DRAM is cheaper? So in SRAM there are 6 transistors are used per bit for 1 bit data storage, and in DRAM one transistor and one capacitor is used for 1 bit of storage. So here in SRAM there are 6 transistors, so the cost is more and time is faster. But in DRAM, there is only one transistor and one capacitor. That's why it is cheaper as compared to SRAM. And use cases used for cache memory registers and in embedded systems. DRAM is mainly used for main memory in computers, laptops, and servers. Now, DRAM has again two types, synchronous DRAM and asynchronous DRAM. So let's see what is synchronous and asynchronous DRAM. Synchronous DRAM operates in a sync with a system clock, providing a consistent timing and performance. And in asynchronous DRAM, it doesn't rely on the system clock. So this is the difference. Timing, if we see, synchronous DRAM, that is SRAM, operates in a sync with system clock, allowing the predictable timing. And asynchronous, not synchronized with a system clock, access times are variable. Now, speed, SRAM, synchronous DRAM is faster due to synchronous operation, and asynchronous DRAM is slower due to its asynchronous nature. Now data transfer supports a burst mode allowing a multiple data transfer, and now asynchronous DRAM transfers one word at a time, leading to a lower efficiency. Now synchronous SRAM is complex design and asynchronous DRAM is a simpler design. Power consumption, if we see, is synchronous DRAM consumes less power and asynchronous DRAM consumes more power.